Hello students, hope you all are doing well. Here in this video, we are going to present you another reaction that you find in organic chemistry. Actually, you could name this as not only a reaction but also an identification test. This test could be done to distinguish those unsaturated substances from saturated substances. Therefore, we could call it an unsaturation test that used to identify unsaturated and saturated substances. So it's a Bayes reagent we are going to employ here. Therefore, students, we could call this Bayes unsaturation test. We are going to talk about the Bayes unsaturation test in this video. So, what are saturated and unsaturated compounds? Let's say, what are saturated and unsaturated hydrocarbons? Students, hydrocarbons are the compounds that you have carbon and hydrogen only. So there are three types of hydrocarbons: alkanes, alkenes and alkynes. When it is an alkyne, it's having carbon-carbon triple bond. In alkenes, you have a carbon-carbon double bond at least. It could be many. So it's in alkanes you neither have carbon-carbon triple bond nor double bond. It's carbon-carbon single bonds only you have there in alkanes. Therefore, students, when you take alkanes, you have the maximum number of hydrogen it's possible there. According to the number of carbons it's having, those alkanes. So when you have certain number of carbons, so there would be possible maximum number of hydrogen representing that carbon amount. That number you have there in alkanes but not in alkenes and alkynes. They lack some hydrogens. They do not have the maximum possible numbers of hydrogens. Therefore, in hydrogens aspect, they are not saturated, but alkanes are saturated with hydrogen. Therefore, students, if we call them, alkanes are saturated hydrocarbon, saturated compounds, but alkenes and alkynes are unsaturated compounds. Okay, so if I give you a few models of alkenes and alkynes, if it is an alkene, you have carbon-carbon single bonds only. So let's say they are alkyl groups. If it is an alkene, you have at least one carbon-carbon double bond. If it is an alkyne, you have at least one carbon-carbon triple bond. Okay, we are going to identify these using a test. We have done that reaction with bromine water or liquid bromine in carbon tetrachloride or bromine in water. Bromine in water or carbon tetrachloride is brown in color. So students, bromine could react with alkenes and alkynes but not with alkanes. So when bromine react, it would get used up. Means bromine's brown color would disappear, decolorize there. If bromine could react with alkenes and alkynes, then alkenes and alkynes could decolorize bromine water or liquid bromine or bromine in chloroform, CCl4, organic layers. But alkenes and alkynes, they could decolorize bromine water, but alkanes could not. Alkanes do not have any reaction, have not got any reaction with bromine water. Therefore, they do not decolorize. They just leave it the color of bromine, brown color as it is. Therefore, when you treat alkanes, alkenes and alkynes separately with bromine water, you could distinguish unsaturated compounds only decolorize bromine water but not saturated compounds. Then saturated compound is the alkane. Unsaturated compounds, it could either be an alkene or alkyne. Therefore, students, you could use bromine water to distinguish between saturated and unsaturated. But it's not about that. It's not about bromine water. It's about Bayer's test. Bayer's unsaturation test. Therefore, we are going to use Bayer's reagent. What is Bayer's reagent? What does Bayer's reagent contain? Okay. So, it consists of potassium permanganate. Aqueous potassium permanganate. Actually, it is dilute solution of potassium permanganate we have here. Then students, it has to be made, the medium has to be made basic. So, bases dissolved in water called alkaline. So, it is in alkaline media we need to have this dilute potassium permanganate. So, it is, let's call that alkaline dilute potassium permanganate. Then it has to be under cold conditions we use this reagent. Therefore, let's call it cold dilute alkaline potassium permanganate. It's cold dilute alkaline potassium permanganate we identify as the Bayer's reagent. Okay, so it is called dilute potassium permanganate. So dilute alkaline potassium permanganate we use as the Bayer's reagent. So you take those alkenes and alkynes. You take them separately. Then you treat them with cold dilute alkaline potassium permanganate is the Bayer's reagent. Then students, what's the color of potassium permanganate? It's purple in color. So then this purple color of potassium permanganate what would happen on that purple color? Would disappear if it reacts, if it is used up for the reaction. So let's find it out. Where would it react with this reagent? Means in which or with which reagents this potassium permanganate under these conditions could react. It's anyway not with alkanes. Alkanes do not have pi bonds. Therefore, this cold dilute alkaline potassium permanganate does not react with alkanes. Therefore, the purple color remains same. So, it is not harmed this purple color. But students, they are in alkenes and alkynes. This potassium permanganate going to react with alkenes and alkynes. Therefore, its purple color would reduce. We call it would decolorize or it would turn colorless. It decolorizes. So in both the purple color of cold dilute alkaline KMnO4 would be decolorized. Then students, it is in alkaline media. You get this potassium permanganate being used up. Potassium permanganate is an oxidant, is a strong oxidant. It would then get reduced itself. It would get reduced into MnO2 in alkaline media plus 4 oxidation state. Therefore, it's possible you to observe a brown colored precipitate. MnO2 is a dark brown solid, water insoluble substance. Therefore, it's possible you to observe a brown colored precipitate as well, decolorizing the purple color of potassium permanganate. They are in alkenes and alkynes, not in alkanes. Therefore, students, you could use this as to distinguish between alkanes and others, alkenes, alkynes together. You can't say this is an alkene or alkyne, but anyway, you could say it is not an alkane if it decolorizes cold dilute alkaline potassium permanganate. But if it does not, out of those three, it is then an alkene. Okay, then let me show you the reactions or products that you would get after this reaction. So students, you need to know what is the possible product given when you treat an alkene with cold dilute alkaline potassium permanganate, means the Bayer's reagent. So this is the alkene you have got initially. whole diode, alkaline potassium permanganate. This pi bond will be opened up and there will be two alcohol groups, OH groups, hydroxyl groups being attached on each carbon. Means, so there will be two OH groups, to those positions of where you have got earlier the pi bond between. So there will be, we call it dihydric alcohol. This substance is having two of OH groups, alcohol groups. It is a dihydric alcohol you get there when you treat an alkene with whole dilute alkaline potassium permanganate. Then students, you could use this product in your conversions as well. When it requires in your conversion steps, converting your starting materials into final products, you could use this reaction as well in your conversions. But we are not going to talk much about the products given by alkynes. But anyway, let me show you some brief information regarding alkynes product. So if we could expect following alkenes, alkynes also would behave similarly as giving, opening up one pi bond, there will be two OHs given on two carbons. Then opening up the other pi bond as well, there will be another two OH groups. So we could expect this kind of compound being given. But students, you need to know this important fact that having of OH groups, having of more than one OH groups, let's say having of two OH groups on the same carbon would make the carbon unstable. Therefore, at the next time, this is going to lose a water molecule as to become stable. So this also will do the same thing. So students, removing two water molecules, those would get transformed into the respective carbonide substances. Okay, so this would become further, this would become a carbonyl group, this is it. This also would become a carbonyl group, this is it. So if you have got these terminal alkyl groups being H's, then it gives you an aldehyde. Then students, aldehydes could further get oxidized by potassium permanganate. Therefore, it would be further bound to carboxylic acids. But in alkaline media, you won't get the carboxylic acid, but it's salt. Anyway, the reaction could be continued if you have these alkynes being H's. Anyway, you have a reaction here as well. Here also you have this potassium permanganate being used up for the reaction. Therefore, here also you would be having the observation, say purple color vanishes, decolorizes, giving you a brown precipitate there. Okay, that's it. By alkenes and alkynes, they make the observation, the decolorization of the purple color of potassium permanganate, but not alkanes. It remains same. Then students, when you check for the oxidation state here of this carbon, if this alkyne also is having another carbon, there won't be any electronegativity difference. Here also, within this double bond also, you have two carbons, the electronegativities are the same, so no difference you get. But there, having CH bond, C is more electronegative than H. Therefore, this carbon would be slightly negative and this hydrogen would be slightly positive with respect to this bond. This bond electron therefore would be drawn more by the carbon. Therefore, it's a slightly or partially taken off an electron. Therefore, it is -1, the oxidation state of that carbon. When you check it for this, here if it is a carbon, there you have got in alkyl group no difference of electronegativity here as well. Then here it is slight negative carbon, slight positive carbon. Then it would be -1 given by that bond, because carbon is more electronegative, it draws the electron from the bonding more towards that. It is partial taken of an electron, so the oxidation number given by that bond is -1, then this carbon has attached to the second most electronegative atom is the oxygen. So oxygen is more electronegative than carbon, so would make it slightly positive, slightly negative. That charge with separation or dipoles you get, they are in the bonding. Therefore, it's a partial removal of an electron slightly positive, means it gives +1 the oxidation number by that. So the oxidation state of this carbon will be 0, +1 -1, it results 0. Then students, the change of oxidation state during this reaction is from -1 to 0 is an increase of the oxidation state. Therefore, this is an oxidation reaction. So when you treat an alkyne also is the same. You get more H groups, therefore it further increases the oxidation state. So in both alkenes and alkynes, you get that alkene and alkyne substance getting oxidized by potassium permanganate. It would get reduced itself. Therefore, this could be named as a redox reaction as well. This reagent, Bayes reagent, oxidizes alkenes and alkynes. Okay. Anyway, its students, then you could use this reagent, Bayes reagent, as to distinguish between alkanes or saturated hydrocarbons from alkenes and alkynes, from unsaturated hydrocarbons. Hope you could understand these simple things. Okay students, further, if you have got any kind of problematic thing or any difficult part here, part that you have not understood, if you have any suggestion, valuable suggestion there, you could mention under the comment box, in the comment box. So then students, we are presenting you these series of videos as supportive videos for your organic chemistry lessons in your A-level. Therefore, it's your obligation is to share these videos with your friends, amongst your friends. Okay, students, it's with the hope as to meet again in another video similar. We are going to round up here in this video. Okay students, goodbye.